So 31, we have tan squared x over secant x plus 1 equals 1 minus cos x over cos x. So first of all, we do an analysis. What do I have? I've got a single fraction on the right-hand side, 1 minus cos x and cos x. And that's already in sine and cos. So the right-hand side fits with the strategy of change things to sine and cos and get a single fraction. I look at the left side. I've got a tan squared. That's related to secant squared. So there might be something to do there. Okay? So I'm thinking about that. And I've also got a secant on the bottom, but it's not squared. So what I'm going to do to start this one is I'm going to start this one using the strategy you most likely would pick, which is change things to sine and cos and then get a single fraction. Then I'm going to do it again with using some other things to see where there might be a shortcut or something else that you could see. So first of all, tan squared. Well, I could change that to sine squared over cos squared. And secant would be 1 over cos x plus 1, which I will then multiply that 1 by cos x over cos x. So in a proof, if you have fractions within fractions, try to get a single fraction in your numerator, a single fraction in your denominator. If you do that, then you can multiply by the reciprocal. So if I add the bottom, you could see that I have a single fraction on the bottom, and on the top I would have sine squared over cos squared multiplied by the reciprocal here, which, or cos squared, cos x 1 plus cos x. Now this cos x will cancel out with one of those cos x's. And so now I'm left with a single fraction on this side, which is cos x 1 plus cos x. So now we've got a single fraction on both sides. I'm going to scroll up so I can still see that. Well, I'm actually going to zoom so we can see where we're at. Okay? So now is the point when we have a single fraction on both sides that we're going to either, and we're not the same. In other words, we're stuck. And I don't know if you remember when we talked about those strategies, I put an S circle beside 3 of them, that when you get stuck, you should think about doing one of these strategies. And those strategies included factoring or build the other side, which is sometimes multiplying by the conjugate. Basically, 2 main strategies. Can I factor or can I build the other side? So I look on both sides. Is there any differences of squares that I can factor? Not really at this point. So if I wanted to use build the other side strategy right now, okay, let's say I want to get my denominators the same. This denominator has cos and 1 plus cos. This denominator just has a cos. So if I multiplied this side by 1 plus cos and 1 plus cos, I'm multiplying by 1. I'm not changing what that side equals to. But I will at least, on the bottoms now, get my denominators the same. I guess I don't need, it's not bad to have brackets around that x, but it's not needed. And what will I have on the top? Notice the top is a factored difference of squares, so I could multiply that out quickly. So this recognition of difference of squares will save you a lot of time, because if you notice that 2 things are conjugates, you could multiply them quickly. So at this point, I got my denominators the same. And now I just look at my numerators. Is there anything I can do here? Yes. What's 1 minus cos squared? It's sine squared. Yes. 9b in the book for sure. Okay. So this one, I did it this way so that we could see the build the other side strategy again. Okay? So this is proof number 1. I'm going to erase what we did. And just because you've proved it one way, these proofs are not something like, oh, I've done that one, I could move on. You can often look at the same proof and say, can I try something else? Or is there a different way I could go about that? In fact, doing that is going to make you a lot stronger at your proofs. These are, I always call these like puzzles because you have to try and figure out how they work out to the end. But there's more than one solution to these puzzles. So in this second one, I'm going to think about tan squared being related to secant squared and see if there's something that I can do with that. So I could change the tan squared to secant squared x minus 1. Right now, sometimes people are tempted to cancel things out. Okay, you have to remember that when you're adding and subtracting, this would get grouped together as a single factor. This is grouped together as a single factor. And the only way factors can simplify is if they're identical. And they're not. However, the top is a difference of squares. So when you move things around with secant squared minus 1, cosecant squared minus 1, 1 minus sine squared, it always makes a difference of squares. And if you can start recognizing difference of squares and factors of differences of squares, like in this case, when I factor the top, can you see that it would be secant x plus 1 and secant x minus 1? And I have a secant x plus 1 on the bottom. And so now these factors are identical, so they can cancel out. And I'm just left with secant x minus 1, which I could change to 1 over cos x minus cos x over cos x. Yes? Is secant x minus 1? No, because that would be 2 steps. The 2 steps that you just did was factor and cancel out. Okay? Because there are students that do this. Okay? This is a very common mistake that we see. Oh, I'm going to cancel this out with this. Positive divided by a negative is negative, so I get secant x minus 1, which is totally wrong. That's not allowed. Right? But sometimes you do not allow things, you get the right answer. I showed you that before, didn't I? Like the 16 over 64, if I showed you that? Where you cancel out the 6's. That's not allowed mathematically, but it works. Do things that don't work to make it work? Half of the number? Probably. Sometimes I should take pictures of the stuff that happens. That's sort of like, wow. But okay, so number 9 from the textbook. Wasn't it? So we have one fraction on this side, cos theta minus cotangent theta over, this is number 9. Page 615, over 1 minus sine theta, and on this side, negative cotangent theta. Okay, so looking at what we have in this question on the left and the right, okay, we have a cotangent, cos and sine, cotangent. We don't have any of those relationships where cotangents with cosecant. None of the things are squared right now, so everything looks like we should go to that regular strategy of changing things to sine and cos. So on this side we'll have cotangent is cos theta over sine theta. So I've changed everything to sine and cos, and now I need to get a single fraction. So in my numerator here, I'm going to need to multiply by sine theta and sine theta. in my denominator, I need to recognize that this is already over 1. So I do have a single fraction in my denominator. Now when I multiply the tops, I'm going to get sine theta cos theta minus cos theta all over sine theta. I'm going to draw a bigger line from my main fraction. I have 1 minus sine theta over 1. So now I can multiply by the reciprocal. This is grouped together. This is grouped together. Okay? A tempting thing that people want to do is cancel out these signs. They're grouped together. Anything that's connected by adding or subtracting groups it together as a single factor. So when I look at those things grouped together, there's nothing that I can cancel. So I'm going to have a look back at the other side and say, okay, it's just cos theta over sine theta. So at this point, I could say I'm stuck. I have basically, once this is multiplied out, a single fraction on both sides. And if I did multiply this out, now this would, I wouldn't distribute the bottom because one of our strategies is factoring. I probably would just write that like that. Okay? And since one of our strategies is factoring or build the other side, and of those two strategies, I would recommend you always look for the factor strategy first, because factoring makes something more simplified on a side. Building the other side makes things bigger. Both strategies work, but it's easier to work with things that are smaller and less complicated than it is that are bigger. So I'm going to notice that in this top factor, that in those two terms, there's a cos theta in common. And so I can factor out a common factor. I could factor out a cos theta and be left with sine theta minus 1. How do we deal with, do you see that these sine theta minus 1, 1 minus sine theta are so close? They're not quite the same. I'd have to factor out a negative. So at this moment, I might even go and say, hey, I'm going to take the negative out here. That would make this one negative and that one positive. And now these two factors are the same. And we're just left with negative cos theta over sine theta. And we're done. Yes? The quiz is just on proofs. I think I've got 6 proofs. That's what we're doing. Are there any other ones you would like to go over?